All right, here we go. So, third term is -2, so I can use my rule to find the first term and the common difference, knowing that it is the third term. So I can simplify that a little bit more, make it look like a sub 1 plus 2d. Okay. Then I can use the other term that's given to me. Times 18 minus 1 gets me that. So that would become 43 equals a sub 1 plus 17. No, I know, but I'm saying it was from. Okay, yeah, okay, yep. 3 was my common difference. Yep, okay, yep, I'm good. I just had to think. Think in my brain. Think in my brain. Okay, now, so I've got 2 equations with 2 variables. How can I solve those? What do we call that? Elimination. That's one way. Substitution is another way. Cramer's rule is a third way. Matrices is a fourth way. Graphing, but we're probably not going to graph it. Yeah. Unless you're criminally insane. Okay? All right? So, I would probably take this first equation here, and I would multiply that whole thing by -1. That gives me positive 2 equals negative a sub 1 minus 2d. That gives me 45 equals 15d. Divide both sides by 15 gives me 3 equals d. Okay? Then I can take that and I can plug that back into this equation. -2 equals a sub 1 plus 2 times 3. And that gives me -2 equals a sub 1 plus 6. So -8 is my first term. Now that I have my first term and I have my common difference, I can go on and write a rule. And that rule is going to be a sub n is equal to -8 plus 3 times n minus 1. Or, if I do some funky math going on in here, -8 plus 3n minus 3, where I distributed that 3 in there, then that would become a sub n here equals 3n minus 11. Good.
Did that make more sense?
It's the same. It's the exact same. It's the same example we did on Monday. I just changed the terms. Okay. All right. So today we are going to be finding sums. Now, 2 words there: finding and sum. Okay. Finding is what they did to Dory and what they did to Nemo before that. Okay. Right. Sum. What does sum mean? But how are we going to get that total? We're going to add them, right? Okay. Sum means add. Okay? You're going to add them all up. So we're going to take all of our terms. So if we had a, let's say, 2, 5, 8, 38 sequence, right? Okay, that's a sequence, correct? Okay. if I add up all those terms, I'm basically going to say 2 plus 5 plus 8 plus 11 plus 38. Right? I just added 3 to the next one. Common difference was 3. Okay. Now, this first one, that is a sequence. Okay? Right? Standard sequence, standard arithmetic sequence. Common difference of 3. First term is 2. Last term is 38. Okay? If I find the sum of that by just adding up all of those terms, now it becomes a series. Okay? We find sums of series. We find terms in a sequence. Okay? So today we're going to be, they're the exact same thing. They have the exact same properties. Okay? It's just the terminology is, if it's a sequence, all the terms are separated by commas. If it's a series, you're going to add them all up. Okay? You're going to find the sum. Okay? So, on Monday we started with a brick problem. A tall brick building has a decoration as shown. If each brick has a height of 1 foot, how many bricks would it take to build the decoration 15 feet tall? Okay? We're getting closer to getting to there. Okay? So, let's figure some stuff out based off of that problem. Okay? First off, how many bricks would there be in that 15th row? 15 feet tall. Each brick is 1 foot. Okay? And there's 1 brick in the first row, and then each row has 1 more brick in it. Okay? Alright? So if I use my rule, A sub n equals A sub 1 plus D times n minus 1, that's going to be A sub 15 is, there was 1 brick in my first row. Each row has 1 more brick. So that's going to be 15. 15 minus 1 is 14. 14 times 1 is 14. Plus 1 is 15. Okay? So, in the first row, we said that there was 1 brick. Then 2, then 3, 4, 6, 7, 12, 13, 14, 15. Find out how many bricks we use. Got to go to Menards. Got to make a Menards run. How many bricks do we have to use?
Just by your calculator and all those up?
What does it say? Do this manually with your calculator.
I can't read that.
Maybe you should move closer to that.
I know what countries are just getting away today.
So move closer to that.
I was just being lazy.
So you could move closer to that. What you got? I get 1 to 1, right? 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15, plus 6 is 21, plus 7 is 28, plus 8 is 36, plus 9 is 45, plus 10 is 55, plus 11 is 66, plus 12 is 78, plus 13 is 91, plus 14 is 105, plus 15 is 120. Okay? Right? Now, makes sense to add up 15 numbers. What if our building was 30 feet tall?
You just have times 120 by 2.
No.
No? Oh yeah, because you add 1.
Because you're adding 1 more to each brick, you know what I mean? Or to each row. So you'd have to add 15 more numbers, right? Okay? Might not be the easiest way to do that. So using or adding manually isn't always realistic. Later on today, you're going to calculate the sum of a series that has 281 terms in it. Okay? Now, your choices there are to use the formula or find all 281 terms and then add them up. Again, I leave that totally up to you. Okay? All right? But to find the summation formula for an arithmetic series, and for only an arithmetic series, because we're going to get into geometrics later on next week, is that, where S sub n is the sum of the first n terms of that series. N, then, is the total number of terms. A sub 1 is our first term, and A sub n is our last term. Sorry for getting you to pass. That's the thing, put more problems on there.
Yeah, we should.
What? Okay. So, you need three things in a series, in an arithmetic series, to find the sum. What are the three things that you need? You need the number of terms, you need the first term, and you need the last term. Okay? You need those three things. If you don't have them, you can always go back and use our explicit formula. Okay? Which was that A sub n equals A sub 1 plus D times n minus 1. Okay? Okay? So, here we go. It says, find the sum of the arithmetic series. Well, my question to you is this. I need n, I need A sub 1, and I need A sub n. Do I have any of those three? But Chia, which ones do I have? You were shaking your head, yeah. Or were you just jamming in your brain? What is the first term? How did you come up with 3 as the first term? Because it's the first number listed in our series, right? Yes. You are. Do we have anything else? What's the last term?
48.
48. Why is 48 the last term?
That's the last number.
Because it's the last number listed in our series. Mind blown. Okay. Do we have n? No. So we got to find n then, right? So let's use our old pal A sub n equals A sub 1 plus D times n minus 1. So that's going to be 48 equals 3 plus, ooh, what's my D? 5, right? My common difference, I'm adding 5 every time. 5 times n minus 1. How can we solve that? You what hurts?
Never mind.
Michelle, what did you say? We could distribute the 5. Could we do anything else? Subtract 3, right? If you want to distribute the 5, but we're going to get the same answer, but let me show you a little funnier way. Okay? So if I subtract the 3, then I get 45 equals 5 times n minus 1. Now what could we do? Divide both sides by 5. Gets me 9 equals n minus 1. And then what? Add the 1. So 10 is n. Okay? Now, if you would have distributed the 5, then we would have gotten 48 equals 3 plus 5n minus 5. 48 equals 5n minus 2. 50 equals 5n. 10 equals n. Same thing.
That way, sure.
Which way? My way or the highway? Which
The
one? Which one?
other way.
My way or the highway?
The other way.
Okay. All right. So now we got everything that we need to use our formula. So the sum of the first 10 terms is going to be 10 divided by 2 times 3 plus 48. 10 divided by 2 is 5. 3 plus 48 is 51. So that the sum of the first 10 terms is 25.5 or 255. 200 double nickel. Ten is the n. Is their number of terms. We just found it. With me?
No.
Yeah, buddy? Yes. No.
Sure.
Maybe. Hey! Sigma notation. We talked about it last week, Thursday, a week ago. It's been a while. Okay? So, sigma notation. Remember sigma notation, a big old funky E. Okay? On the bottom of that funky E is some variable and a starting number. And that number is the number that you plug into your rule, and that gets you your first term. Yeah, buddy? Okay. Then on top of our funky E is our ending number. Okay. Plug that number into our rule, and that gets your last term. And then behind the funky E is the rule.
Pretty cool.
Hunter! Come on, Hunter! What did I do?
Can't have anything nice.
This is why we can't have nice things.
Hey, I'm sitting down. I can't touch the board. Oh yeah, I can't move my mind.
Yeah? What? Okay, you put the rule behind the funky E.
Oh yeah.
Yeah, like a book. Okay? Alright? Okay? Okay? So, looking at these two sequences, or excuse me, these two series. Now, sigma notation, just as I like to say, f to the y to the I, okay? Sigma notation means you're going to find the sum. Okay? If it's written in sigma notation, what I'm really asking for is the sum. Okay? Okay? Sigma means sum. Alright? So, if I say write this sequence, or write this series here in sigma notation, okay? First off, I would need to find my first term, or figure out how many terms I have. Well, there's my first term. There's second, third, fourth, 5, and 6 terms. So there's 6 terms there, right? Okay. So so my a sub n is my first term plus my common difference. What's my common difference, D? -8. I'm subtracting 8 each time, or I'm adding -8 each time. And then that's going to be times n minus 1. So I can make that look pretty. -8 plus 8. So I get a sub n here as -8n plus 24. And if I check that, if I spot check that with, let's say, 5, negative 8 times positive 5 is negative 40, plus 24 is negative 16. So it works out. Okay? I just spot checked it, the 5th term. Okay? All right? So my sigma notation, based off of this series, is going to be, first I start with sigma. I'm going to go with my variable is n. I like n. Okay? The book likes I, just so you know. Exactly. Okay? And I'm going to go how far? What term am I going to end on?
6.
The 6th term. So the 6 goes up top. Okay? And then I put my rule. Negative 8n plus 24.
This is where I'm a little confused on everything about this. I thought A of n, then
A sub n,
A sub n is the last term.
it is the last term. Or it's any term in the sequence or series.
Okay. So, but A of n can
A
also
sub n,
A sub n can also be the rule.
it is the rule.
But it's all,
Because it's used to find any term in the sequence or series.
A sub n is also negative 24 in this
A
case.
sub n is the last term also.
So it can also be negative 24.
Okay? Find me the sigma notation for the second series. So I get sigma starting at 1, ending at infinity of my rule 7n minus 4. Yes, Michaela, it's infinity because dot dot dot's at the end.
Wait, real quick. Again with the shouting. On the left one.
Uh-huh.
Why didn't you plug 6 into n? Because we know we have 6 terms.
Because I already know what that term is. I already know that the 6th term is negative 24. I just needed to know where to stop. That's why I counted. I needed that top number.
Yeah.
That's why I counted up to 6. Over there, I didn't have to count because it goes on forever, so I know it's going to infinity. If it would have stopped right here, then this all would have been the same, except instead of infinity here, it would have been 5 on the top. Okay?
Come on.
I know. Failing you again. All right, let's find the sum. What are the 3 things that we need? Okay. Okay. And how many there are. All right. So, which one do you want to find first? The last one? The last term? Okay. So how am I going to find a sub n? No, it is not 65.
It goes up to 65th term.
How do I find the last term? I'm going to take my upper limit and I'm going to put it into my rule. Oops, I forgot the O. Okay? So I'm going to take 65 and I'm going to put it into my rule. 3 times 65 is 195, plus 2 is 197. So my last term is 197. How am I going to find the next thing that I need? Plug in what?
1.
I'm going to plug in my lower limit to find my first term. I'm going to use the lower limit. So in this case, I'm going to plug in 1. 3 times 1 plus 2 is 5.
Where's your board sheet?
Hey, people are just passing time. Okay. What? And so now I need the total number of terms.
65.
How do I find that? Because
The
it's
upper limit.
no, it's not just the upper limit.
Is it what? The one minus the upper minus the lower?
It's the upper limit. What? Minus the lower limit. Nope. Top minus bottom. Plus. Anybody remember? 1. So it's upper minus lower plus 1.
So 65.
In this case, it's 65.
That's I remember that.
So it's 65 minus 1 plus 1, which is 65. Bless you. Okay. Now, do I have enough to find the sum? Yeah. Okay. So the sum of the first 65 terms is going to be 65 divided by 2 times 5 plus 197. That's going to be 65 divided by 2 times 202, which is going to be 6,565. $202 divided by 2 is 101, times 65 is 6565.
Okay. Whatever you say. I'll just go with it. Freaking insane.
That was easy, because the 202 divided by 2 is 101. So whatever you put out in front, it's going to be that repeated.
Alright.
If you put 9 out in front, it's going to be 909.
Yeah, that makes sense.
You're gonna, if you, 101.
'Cause
202 divided by 2 is 101.
Times 65 is 65, 65.
With me? When you multiply by 101, it's whatever you're multiplying by repeated twice. So if it's 82, 82 times 101 is 8,282. Know what I mean? Okay? Alright! Jingle bam! First term I got 64. Last term I got 952. Total number of terms I got 75. Yep.
Oh my god, I messed out almost because I put 8 with 80. Now I
Oh.
hate my life.
Oh. So the sum of the first 75 terms is going to be 75 divided by 2 times 64 plus 952. So that's going to be 75 over 2 times 1,012? 16? Oh yeah, it's at 64. Okay. which is, if memory, let me think, because that's 508 times 75. I'm going to go with 38,100.
Gee, that's like,
16
isn't it on the board next to it?
Shh. Don't give away all my tricks. It's right there, Kim.
That must be the answer.
I probably gave it away when I said if memory serves me correct.
Wow, I wonder what that
No,
next
I know
number
that thing
is.
from the beginning of class.
Purposely writing it down.
You didn't just notice that
It's
first.
gonna be
No,
this
I
one.
noticed that from the beginning of
Oh,
class.
it's been there almost every time we do examples like that.
Anytime we do an example, I usually have them written somewhere. Yeah.
You do
Yeah?
sure.
Okay. So, top minus bottom plus 1 gets me 281. Plug in the bottom number, I get negative 12. Plug in the top number, I get 1,108. So the sum of the first 281 terms is going to be 281 divided by 2 times negative 12 plus 1108, which is 281 divided by 2 times 1,096, which is 281 times 548, which gives you
Let me think, I can do it in my head.
153,988.
Yeah, I did it in my head.
That's good.
It's not on the board.
It's not on the board, or in the binder that's open right next to you, too.
Oh, I didn't even know that was there.
Okay? Here is your 12.2b homework.
Fun. Why
It
did
will,
you put fun?
because it starts with your 12.2b homework and it ends with fun.
Maybe fun comes after
No,
it
it's true.
ends, but it doesn't end with fun.
No, it actually kind of does. Like you're happy. because,
Since there is only 5 problems to do tonight for your homework, yes, thank you. Okay. Or I should say you're welcome. We'll have it due tomorrow.
I'll do that tomorrow. Thank you for your service. You email it to. What can I do?
I know. You can just bring it to me tomorrow at the state hockey tournament. Yeah.
Oh, right.
Wesley's gonna be the only kid that shows up before.